Good evening and welcome to ASMR Chemistry. We're going to be talking about limiting reagents, and I wanted to do it in a way that combines creating what's called an ice diagram that oftentimes is used for different types of problems, but I think it can also work really well for calculating limiting reagents. So let's get into it. And by the way, I'm really glad you're here. Thank you for all the lovely comments that I get. I'm so excited that there's been a lot of activity, so I really appreciate it. All right, so let's do this. Limiting reagents or reactants. So sometimes these problems, they don't use the word or term limiting reactants in the problem itself. So part of doing these types of problems is recognizing in the first place that that is what you need to do, is take into account which one is going to be limiting. So let's look at a very iconic chemical reaction, and that is the reaction between nitrogen. This is all gas phase, by the way. Nitrogen reacting with hydrogen to create ammonia. H3. Okay. And we are going to be given the information that if we have three moles of N2 of our nitrogen and 6 moles of hydrogen, how much of the ammonia can be formed? So here we would assume that whichever one is limiting, oh, I'm sorry, I should have, there's significant figures here. This should be 6.0. Okay, so it's 3.0 moles and 6.0 moles. Okay, so given these amounts, how much can be formed? So which one's going to run out first? And that one that runs out first, that is going to then dictate how much of the ammonia we can get. Okay. So first we want to look at this ratio, okay? So we've got 3 moles of this, or sorry, we have 3 moles of this, but it's a 1:3 ratio. We have 6 moles of the hydrogen. It's a 3:1 ratio. So I'm just saying that to look at the point of view of 3:1 versus 1:3. And with that, we can say, okay, let's see how many moles of hydrogen do we have, right? And if we take the moles of nitrogen that we have and take this ratio into account, how many would we need to completely react? Okay, so if we have this many moles of nitrogen, that's what was given. see what we would need. So let's convert moles of nitrogen to moles of hydrogen by using the stoichiometric ratio. And we would need, there are 3 moles of hydrogen for every 1 mole of nitrogen. This ratio here is from this ratio here in the balanced chemical equation. Okay, so now going through calculating moles of hydrogen by this, so now moles of nitrogen cancels out. 3.0 times 3 is 9.0 moles of hydrogen. Okay, so what does this mean? This means this is how much we need. How much is needed to react with 3.0 moles of nitrogen. Okay, so look at this. Do we have 9 moles of hydrogen? No, we do not. We were told that we only have 6 moles of hydrogen. But in order to fully react with those 3 moles, we would need more. We need 9. We don't have the 9. Okay. So that means that our hydrogen is the limiting reactant. All right. Let's try it the opposite way from the other point of view, because maybe if you were doing this reaction and you thought, okay, I am going to calculate a number of moles of hydrogen I need. Instead of doing that, you started with how much hydrogen you had, and you were like, okay, let me make sure I have enough nitrogen. So let's do it the other way and calculate moles of nitrogen. So we start with the 6 moles of hydrogen that we have. And we use that stoichiometric ratio. There's 1 mole of nitrogen, 3 moles hydrogen. Okay, so now moles of hydrogen cancels out. And we would get 6 divided by 3, 2 moles of nitrogen. Okay, so we would need 2 moles of nitrogen. How much is needed to react with 6.0 moles of hydrogen? Okay, so let's look at these two. These are kind of checks. You could look at them before doing the actual problem. You want to see which is the limiting reactant. We did this check, we did this check. And the conclusion from this one is that we don't have enough. That hydrogen, in other words, limiting. Okay, we don't have enough hydrogen. Here, this is the amount of nitrogen we need to react with the amount of hydrogen we have. We need 2 moles. Check it out. We have 3 moles. So we have extra. We have plenty. Of nitrogen. So we have determined hydrogen is the limiting reactant. And so now we can look back at the question that's being asked. If we have 3 moles of nitrogen, 6 moles of hydrogen, how much ammonia can be formed? All right, so that means we need to base the calculation on the limiting reactant, which is hydrogen. Okay, so let's start with the moles of hydrogen, and we will calculate moles of ammonia. So now we'll start with limiting reactant, moles of hydrogen. And now we are going to use the ratio between hydrogen and ammonia. We have 3 moles of hydrogen for 2 moles of ammonia. Moles of hydrogen cancel out. 6.0 times 2 is 12, divided by 3 is 4 moles of ammonia. Okay, so this entire problem was done in terms of moles, okay? Now, it is very likely that a question could come upon you where instead of giving numbers of moles or asking for number of moles, it would want mass in grams. Perhaps because these are gases, maybe it's asking for volume, and you would need to use the ideal gas law. So it depends on what the amounts you're being given or asked for that would add additional steps to this type of problem. But what we're looking at right here is the core of this type of problem with limiting reactants. We must compare the number of moles of each of those reactants in order to solve this problem. We can't compare in terms of masses or volumes because that's not going to be looking back at the balanced chemical equation, taking into account what these ratios are. Okay, so I hope this was helpful for you to understand the essence of this type of problem and to help you then apply it to any kinds of problems that you see in your homework assignments or quizzes or exams. All right. Well, thank you so much for being here with me. It's so lovely to be making more videos. I will keep making them and keep giving me your requests. It's really great to hear that feedback and to send messages back and forth in the comments. So keep coming. All right, thank you so much. I'll see you next time.